So I'm going to round off this session with a little bit about the homework. Now, a few people have been a bit worried by the use of the term homework. Don't worry, it's only for fun. We're not going to mark you, it's not designed to stress anyone out. But what we're trying to do is find a way of making these virtual conferences work better, virtual workshops work better, because when we've done bioinformatics workshops in the past, we've had lots of people in classrooms and had people, you know, follow commands and us kind of hovering around, helping with commands. And, you know, it doesn't work that well, to be honest with you, but that's the way we've done bioinformatics training in the past. And these virtual workshops is an opportunity to try and find maybe a new model that works better for bioinformatics training. And the idea of homework is really about that idea. And so what we've done is we've given you some example exercises to go and do in your own time. So if you have time today, tomorrow, feel free to do them then. And I will be reviewing the results tomorrow at the end of tomorrow's session. So that might be a good way of doing it. But if you don't have time today, you can do it whenever you want. The homeworks assignments are all available through the course website, which you should have the link in your email. So I've split the homework into two sections. There's today's homework section, which relates to the topics that were introduced today. And then there's more homework tomorrow, which will relate to the 3 presentations that we have tomorrow, which is going to be on phylogenetics, molecular epidemiology, lineage assignments, and new variants. So there are 5 pieces of homework that you may want to try, depending on your interest, really. So Josh has set some homework about if you want to design your own primer scheme, maybe for a virus that you're interested in that's not SARS-CoV-2, or maybe you want to make a better scheme than Josh's. He's given you the instructions for how you can run the primal scheme software and some examples for you to go through. Will, who presented on the Arctic nanopore pipeline, has a MyBinder site that you can run through the pipeline, run through the commands and see the output. And you could also try and do that yourselves through Conda on your own laptop. Nabil has a fun tutorial just thinking about some of these gotchas that he mentioned in his talk, things that can go wrong when you're running the sequencing center for SARS-CoV-2. So just some kind of practical questions around problems that can occur. And there are a couple of basic tutorials. One is just simply to install Bioconda and play with it. Bioconda is very important in terms of the software that we've introduced today and the software we'll talk about tomorrow. So if you haven't looked at Bioconda, I would definitely recommend looking at it. And then the final thing to mention is Lab on an SSD. And this is I was hoping that this is the second workshop that our colleague Radoslav Poplaski hasn't come to because he's busy in the data center keeping CLIMB running. But what he has done is develop a bootable image. This is something that you can use with a USB stick or an SSD drive or even a conventional USB hard drive to give you a bootable Ubuntu Linux environment. And the benefit of that is that if you are running on a Windows PC or certain Macs and you want to use a Linux environment and want to use some of the software more easily that we've talked about, this is a very easy way of you just getting to grips with Linux. You get a blank USB stick, make sure it's not something with something important on, because if you install Lab on an SSD, it will erase the contents of that stick or drive. You can install the image with a bit of software called Etcher that will run on your Mac or your PC. And then you should be able to plug it in, reboot your laptop, hit a key in order to bring up your boot menu, and you can boot from that stick. And that will give you the Arctic tools pre-installed, Conda pre-installed, and that may be a very useful way for you to do MinION sequencing or nanopore sequencing, because it also has the nanopore software installed on it. And we found that to be very useful when training, particularly if you are interested in getting to Linux, but you haven't got a Linux machine available. Just to talk about Conda, I mentioned this already, but most of the practicals and most of the software we've talked about typically install in a Conda environment. First thing you need to do if you want to use Conda is to install it yourself. So you can simply follow the instructions on the Conda website to do that on Mac and on Linux. It's quite easy. That should just work, whether it doesn't really matter what version of Linux you're working on. Ubuntu, CentOS, whatever, should work fine. Mac as well should work fine. On Windows, it's slightly harder. So your options there are you could use the lab on an SSD, which turn your PC temporarily into a Linux box. You could install a virtual machine environment like VirtualBox and run Linux within there. You could use the lab on an SSD image within VirtualBox to make it easier. Or if you're on a later version of Windows, Windows 10, you should be able to use the Windows subsystem for Linux, which gives you an emulation of Linux within your PC. And if you have any of those approaches to getting Linux on your Windows machine, you will then be able to install Conda and do the tutorials. So what's RADS doing? RADS is in the data center, racking servers up and connecting servers up and installing servers as part of an investment that MRC have made recently in CLIMB and in our infrastructure. And we're going to use those machines to help offer more cloud computing to particularly for COVID-19 response globally and for global pathogen surveillance. So we will keep you updated on the progress of that via the Slack, but software like Herald that Will Rowe introduced are going to be the interfaces for using CLIMB if you're not in the UK and you can't use CLIMB at the moment. So reminder that we're going to do the support for the homework and the support for the course overnight on Slack. So if you're not on the Slack, you can go to the course website and find the invitation link. Once you've used the invitation link, you'll get onto Slack. You can do that through the web browser or through the Slack client, whichever you prefer. And the course instructors will be sitting around on there and can hopefully answer any questions you have on the homework or any other questions that might have occurred to you during the course. So that's the end of this session. Just that's the end of the session. And let me just check if there are any more questions in the chat. Tracy, did you miss a link to the homework? The homework is on the course website. And we'll post a link to the course website again in case you don't have that. But it's on the course website. Kurt's asking, would that bookable Linux environment work on a Windows tablet? Oh gosh, it might do, but typically Windows tablets have proprietary hardware that are not very well supported on Linux. So I would expect you might be able to get it to boot, but you might find like the touchpad doesn't work or the keyboard, the virtual keyboard doesn't work. So I wouldn't necessarily recommend you trying to do that on a Windows Surface or Windows tablet. You might be better in that case doing it through a virtual machine environment like VirtualBox. I think that would probably work better. But yeah, if you can plug in a USB keyboard and mouse, then you might increase your chances of that working. But that wouldn't be my ideal hardware. Give it a go, but don't blame me if it doesn't work. Okay, are there any other questions from anyone before we wrap up this second session? I think it's been a really interesting session, quite diverse talks and some new talks, which is really, really nice. I'm not seeing any more questions coming up in the chat, so I'm going to stop the recording and end the session, and I'll see you over on the Slack channel, I hope. Okay.